Hi, Regina. This is the rover, all right? And the class's idea last year was to have an auger that you can drop from the rover. We don't need to have the drop technology. We just need to just have this auger here, all right? So this is going to turn, and as it turns, by a screwing motion, it will lift the regolith. And then Eric's idea was that we would have a conveyor belt here, a conveyor belt here. The conveyor belt would take this regolith and move it, and it will drop that onto this hot heat sink. This heat sink is some solid piece of metal that needs to be kept cooler than the machines on board that are producing heat. Machines on board that are producing heat include the lights. This light, it produces a lot of heat. Maybe you have a radio, right, for communication that's producing heat. Maybe you have a little electric generator to generate electricity that's producing excess heat. And whatever you have on board that's producing heat, they all have to be connected to this heat sink thermally, meaning connected via some material that conducts heat, such as a metal pipe or a thick metal cable, so that when these get hot, this piping or cabling will get hot, and this will end up getting hot. If this is kept cooler than all of this material that's getting hot, then these materials will be able to cool off by conducting their heat here, right? That's because, of course, in this universe, if you have a hot object and a cold object, and you put them together in contact, well, the hot object is going to get colder, and the cold object is going to get hotter until they're both kind of warm, neither cold nor hot. Right? So that's the goal. We just don't want this to melt because of its own heat. We don't want this to melt the car, and we don't want this to melt its own components. Okay, that's why we're doing this. Now, the regolith is going to drop onto this heat sink, right? And this is cold regolith. How do we know it's cold? Because Sean's idea was to put a temperature sensor right there. I mean, the temperature sensor is a thermistor. It's very small, very tiny. It looks like a wire. And it can be attached in there by the method of your choice. As a class, we didn't figure out how to attach this. Are we going to use tape, glue, drill a hole, tie it in, solder it? We haven't decided that, okay? Now, the cold regolith, it will be dropped onto this heat sink, and then it will fall to the floor, right? Now, the idea is that we will cool down the heat sink by conduction, actual contact with the cold regolith. The current state of the art is to cool things in space or on the moon by radiation, but the current state of the art is not good enough because radiation is too slow. What we do on Earth is convection. The heat sink in your computer or in your laptop works by convection, and also with a fan. However, there is no air on the moon, and so a fan is useless, and convection won't work because convection requires a fluid like air or water to move the heat. All right, so we're going to try this by conduction, and our hypothesis is that conduction is going to be faster for heat dissipation than just radiation alone. Okay, so the machines in the rover are in use, and then they're getting hot, and so some regolith is lifted from the ground and dropped onto the heat sink, right? And then this machines are continuing to be used, so the rover moves to another location to get fresh cold regolith. Keep on doing that. Get fresh cold regolith, fresh cold regolith. During the discussion last year of this, we thought maybe, or some group, I forget which group, some group thought that we could just drag the heat sink through the ground. But we realized that we cannot do that because what if you want to stay in one spot? For example, what if you're studying with the light some feature on the moon, or you need to take some pictures, or you need to send a radio signal that requires you to be stationary. I don't know what kind of radio signal that would be. But anyways, we need the ability to move. We need the ability to be on the move, so we can't just we need the ability to be stationary. We have to have the freedom to not just to move, but also to sit in one spot. So if we're going to sit in one spot, well, everything's going to melt because this is going to be very hot. So that's not good. So we can't just sit in one spot. We have to be able to. We can't always be on the move. We have to be able to sit in one spot. And to do that, we have to have the heat sink not on the ground. We have to lift dirt and drop it on the heat sink, right? It's kind of simple idea. Not sure if it's going to be practicable for use on the moon or not, but that's why we're trying it. That's why we make the model.